In this video here, I'm going to talk about state of matter, solid, liquid, and gas, and melting and boiling points, and a little bit about how polar and nonpolar molecules come in to determine this and the shape of the molecule itself. So first things that I want to review is the general properties of solids, liquids, and gases here. And so a solid has a constant shape, so it does not change. So I'm just going to write no for no change here. A liquid shape will change based on its container, so I'm going to put yes. And a gas, which is misspelled here, we're going to fix that. A gas also changes its shape based on the container. Then when we go to volume here, the volume of solids do not change. A liquid should have the same volume no matter what container it's in. So this is why you can buy a 12-ounce can of Coke and pour it into a glass, and it should still be 12 ounces. It should not change. And gases, on the other hand, do change based on their container, the volume, and how much they're compressed. This is why when you spray cologne or perfume, it'll eventually spread out throughout a room. Solids are not compressible, either are liquids, but gases can be compressed into smaller containers. Now, one thing I do want to bring back with electronegativity and polar and nonpolar is that the reason why certain things are solids, liquids, or gases based on the temperature they're at is there are interactions between molecules. Okay, so with solids, there's a lot of interaction going on between the molecules. Liquids, there's some. Gases, there's hardly any, other than when they collide. And it's these interactions that are going to determine what temperature the material is a solid, liquid, or gas is at, and it's based on whether that molecule is nonpolar, polar, ionic, and also the size of the molecules. Okay, so a polar molecule will tend to have a higher melting and boiling point, which I'm going to talk a little bit more here in a second, than a nonpolar molecule. And the same thing with molecules that are larger will tend to have higher melting and boiling points. So here I have what's called a heating curve, and so this is a pretty generic one. And so, but this tells us exactly the melting and boiling point of material. So melting point is the temperature at which it goes from a solid to a liquid, and boiling point being where it goes from a liquid to a gas. Now it's all dependent on temperature here. So I'm going to use S for solid, and MP for melting point, L for liquid, BP for boiling point, and G for gas. It does not matter what the material is. It's always going to be in that order: solid, melting point, liquid, boiling point, gas. It's just a change in the temperatures at which it occurs. Now, if you notice, over time, if we're heating up something like water, which is ice is a solid, that temperature on that solid increases, and during that time what you're getting is the molecules to start to move faster. They're getting more kinetic energy from that heat. Now, we don't think of solids as moving, and it's not movement like we're used to seeing. This is vibrational movement here. So these molecules are starting to vibrate in place more and more as they get more kinetic energy from the heat, and so the temperature of that material is rising. And but then we get to this melting point and it stops increasing in temperature. And the reason behind this is that at this point, all that heat, that energy, is going into breaking or interrupting these attractions between molecules that hold it together as a solid. So what you're getting is those molecules changing from a solid state to a liquid state. And so there's no increase in temperature because all the energy is going into breaking those interactions. And that's referred to as intermolecular interactions there. Once the material has reached a complete liquid state, or mostly liquid state at this point, then the temperature will start to increase again, because all that heat is going into kinetic energy, and so the molecules are starting to move faster and faster until they reach that boiling point. At which point, again, same thing. We've got to break any remaining interaction between these molecules and get them to spread out as gases. And so the temperature stops increasing again, because all the energy from that heat is going into breaking those interactions. Once it's a gas, then it can start to change again and move faster. What you'll see is, if it's depend on the molecule or what you're looking at, the melting and boiling point is going to depend on whether what the size of the molecule, whether it's polar or non-polar, and the temperature that it's at. And so all that changes that way. Now, the last thing that's been some confusion is, let's say I want to boil a 12-ounce cup of water versus a swimming pool full of water. All right. Well, it doesn't matter what temperature or how much of the material that you have for what temperature it boils at. So water will always boil at 100 degrees. It doesn't matter how much you have of it. The only thing that's going to change is the amount of time that it takes to get there to that point. And so this is the change in state of matter, solids, liquids, and gases. And so you'll have some practice here where I'm asking you to graph and label it. And then you're going to take a short little quiz with some information to answer about it then. Good luck. Thanks for watching the video.